Okay, so now we're going to look at the table method for solving systems of equations. So let's pretend that we don't already know the solutions from the graph, and let's try and find it using a table. So you want to have both of the functions already typed into Desmos, and what you're going to do is you are going to click on this edit list icon. We'll do it first for f of x, and then you're going to click on convert to table. All right, so now we see f of x as a table. It gives us 5 inputs with the 5 outputs. If you want more points, you type it in. So if I wanted the output for the input of 3, I type it in and it's 0. All right, now let's do it for g of x. So click in the box for g of x, go back up to edit list, and click on convert to table. And you'll see the similar table here. All right, same 5 inputs. So we are trying to find the intersection point from the table. So what I'm going to do, so we don't try and look at the graph, even though we already know, is I'm going to unclick on these guys and it'll take away the graph. All right, so now I'm not tempted to look. So you can probably think of some challenges with tables when finding points of intersection, right? It's not as obvious where the points of intersection are. But we can still find them. While we're doing this, I want you to think about other challenges that may present us when we're using tables to find solutions to systems. So when we have an intersection point, that's when the functions are the same, right? They have the same point. So what we want to do is look at the table and find the same points. Well, let's see if it's already there. What if we have one already? So looking at the tables, right, I'm noticing that for the input of 2, right, so up here, input of 2, I have an output of 0, and down here for g of x, input of 2, I have an output of 0. So these two functions intersect at the point 2, 0. So that would be one of the intersection points, all right, because they share, for that same input, they have the same output. -2, -1, 0, and 1, they do not. So we kind of have to guess where this is going to happen. So let's just keep on typing. Let's see, I'll type a few. For f of x, go to 7. All right, and I'll do the same thing down here for g of x, and then let's see if we get any same points. All right, so I'm going to scroll back up. All right, so we have the new points, 3, 0, 4, 2, 5, 6, 6, 12, and 7, 20. Now I'm going to look at g of x, see if any of those are the same. So it might take a few minutes to look through and see if any of them are the same, just compare row by row. But it looks like they share the point. Look back up here, 6, 12 is here in f of x. If I scroll all the way down, 6, 12 is here for g of x. So these guys are the same, they would connect at the point 6, 12. So there are the two intersection points. Now I'll show you when the tables are side by side and we can clearly see where the intersection points are. So here we have the two tables side by side for g of x and for f of x. And what I'll do is I will draw a line in the middle to show, to kind of divide them up here. All right, so we have table on the left-hand side of that line I just drew, and then the second table on the right-hand side. So if we put them next to each other and we match up the rows here, we can see that they both share those points, 2, 0, and 6, 12. This just looks a lot nicer, and now you can see that they match up like that. And all the other inputs and outputs are different, so they would not intersect at those points. So think about some challenges that the table presents versus the graph, right? Try and think of when the table would not be as efficient as a method to use. When would it actually not even work is something you should be thinking about. My last note will be, remember when you are using tables as your method, you want to keep in mind the function families that you're using, right? This example, we had linear and quadratic, and the options are no solutions, one solution, or two solutions. So, no solutions meaning imaginary, same thing as two imaginary, one real solution, and then two real solutions. So if we had two lines, it would be no solutions where the lines are parallel, one solutions when the lines cross at one point. Obviously, when one's increasing, one's decreasing, or when one's undefined, when one's horizontal. Or you could have infinite solutions when the lines are the same, they're stacked on top of each other. So keep that in mind also when you're using tables, because there may be more than one solution.